Interfaces and abstract classes. Abstract methods are methods that contain only the method header followed by a semicolon. These methods must be completed by any class that implements an interface. We'll talk about what an interface is in a little bit. The format for an abstract method is public abstract, whatever your return type is, the name of the method, followed by some parameters. Some notes. Abstract methods cannot be static or final. That should be keyword. That's why I can't read that, because it doesn't make sense. So we're going to mark that out. The keyword abstract is not required when writing an abstract method, but it's recommended to add it. Interfaces are basic files that work as a requirement list for other classes. Interfaces can contain public attributes, static methods, and abstract methods. Notes about implementing an interface. An interface can implement an unlimited number of interfaces. Usually when you extend a class, always when you extend a class, you can only extend one class. But when you implement interfaces, you can implement an infinite amount of interfaces. When you're implementing multiple interfaces, you just list off the name of each interface separated by a comma. Creating an interface. Public interface, we don't say class, whatever we call it as a file name. Then we have any of the public static final attributes we want, followed by a list of abstract methods that have no code in them. They're just abstract methods with semicolons behind their header. Implementing an interface. A class can implement an infinite number of interfaces, as I said earlier. To implement an interface, use the following format. Public class, whatever you want to name it, any possible extension, like extends some class, space, implements, and then interfaces. And those interfaces could be separated with a comma. Here again I say when you implement multiple interfaces, they must be separated with commas. Example, public class frame extends JFrame, so its parent class is JFrame. It implements runnable and mouse listener. This means it's going to have to write every method listed in runnable and mouse listener. The runnable interface has a method called run. Mouse listener has mouse pressed, mouse released, mouse pressed, and I believe mouse entered and mouse exited. So anytime you implement something, you agree to write every method they list because all of their methods are abstract. Abstract classes are exactly like classes with two main differences. Abstract classes can contain abstract methods, but you cannot create an instance of an abstract class. Note, any class that extends an abstract class will gain all of its methods, attributes, constructors, but must write every abstract method the abstract class contains. So if you extend an abstract class, you're agreeing to write all the methods that it lists that it did not write. Extending an abstract class. It works exactly like extending a class, but you must override every abstract method listed in the abstract class. And I know I've said that before, but... Alright, creating and storing objects. Format is static type, whatever you want to call it, equals new dynamic type, followed by parentheses because we're invoking a constructor. Now, for example, we might have, I think I have examples about this later, but normally you're used to seeing string a equals new string. In this example, our static type and the dynamic type are both string. Now I'm going to show you something else. I'm going to put object O equals new string. And this looks a little bit weird, but it's valid. And let's go ahead and in the parentheses of the string give it some text like hi, period. Let's make that period a little bigger. So here we have a static type of object and a dynamic type of string. Let's read and figure out what that means. The static type of the variable, the static type is the type of the variable, and it is the type used when the program is compiling. The dynamic type is the type of the object that was actually created. When the program is running, the dynamic type is used. So if we were to compile and we said o.char at 1. Well, we know, first of all, that our string at spot 1.
Students, it is now 3 o'clock.
We're going to hold for the announcement.
Sponsor, coach, or attending a tutorial, exit the building at this time. Thank you and have a great weekend.
It is Friday, as you heard. So we're going to go back to this. If I said o.char at 1, the code actually wouldn't compile. Even though we really created a string, at compile time, when we're trying to compile, it's using the static type. It thinks, oh, O's an object. We really know it's a string, but it thinks it's an object, and it's like, there's no char at method. That's silly. So it wouldn't actually compile this code. Well, first of all, it wouldn't compile because we're not doing anything with it. But if we did SOP and got rid of that, let's do the eraser. So now that that's been erased, this wouldn't compile because even though we did SOP o.char at 1, it thinks it's an object, and objects do not have a char at method. But let's say we did so let's mark this out. We're done with that example. If we did SOP o.toString, let's get a string version of this object. Normally, when you try to print an object, its toString method will print what type of variable it is, or what type of data it is, followed by its memory address. But the toString for a string just returns its text value, which is hi. So here, even though object has a toString method, when the program's actually running and we call the toString method, it says, oh, the object we're looking at is a string. Let's call the toString method of the string class. And it runs hi. The reason it's able to actually run that and it can't run char at is because the compiler thinks it's an object. And it's like, oh, objects have a toString, great. Then when the program runs, we have o.toString, and it's like, okay, O's really a string. That's the dynamic type. Let me call its toString. And everything works great. I missed something in the slide that I just did a second ago, so we're going to pull up and see this example. Object O equals string hi, period. So initially I told you that o.char at 1 would not compile, so I'll show you that is the case. It says can't find symbol, and it can't find o.char at I. Oh, up here I should have said new string, so let's get new string in. Compile, cannot find symbol o.char at I. But if I go over here and I compile my program, it's perfectly happy with calling a toString method because objects have toString methods. When I go print it, we get hi. So now we're left with how can we actually make that o.char at 1 method invoke. So that is done through casting. We're going to tell the computer that it's wrong in what it thinks. So system.out.println, and how we do that is we say, just like we cast with ints, we say cast, I want to treat the next thing as though it were a string, O. So here I'm casting O as a string. So treat O as though it's a string, and then do char at 1. So we're telling the computer, you know, in this one circumstance, treat O as though it were a string. And it's like, the compiler's like, fine, you know, you're probably right. And when it goes to compile, it is able to invoke the char method because its dynamic type is string. Alright, cool. I had gotten a call, so I paused it. Continuing on. Is-a-has-a relationships. Is-a relationships. The first item fits a category through an inheritance relationship. String fits the following categories. This is an example. String is its static type. So that's just the type something is. So when you make a string, it's a string. Object would be the parent class of string. And string implements comparable, so it also fits the category of a comparable. It agrees to write all the methods listed in comparable, so it fits 3 categories. A string is a string, it's an object, and it's a comparable. Has a relationship. The item has the listed attribute. A student has the following items: name, student ID. In our example we created earlier, we had students have first names, they have last names that come from person, and a student ID comes from student. So I wrote these slides before I wrote that example. Instance of. Determining if an object is a relationship to a class, abstract class, or interface. Here we say object O equals new string, like I did in the other slide. Oh, sorry, the format for this command. Variable name, instance of, type. It'll give you a Boolean result. Gives you true when that relationship is valid. O is an instance of string. Yes. O is an instance of comparable. Yes, because a string's also a comparable. Let's write out the words. So up here, O is an instance of string, true. O is an instance of comparable, true. O is an instance of array list. No, strings aren't array lists, so this one would be false. Polymorphism. Polymorphism is the ability of an object to be treated as any one of its types. Student S equals new student John Smith. System.out.print s.getFirstName. Here S is being treated as a person because it's accessing data from the person portion of the class using getFirstName. Here S is treated as a student because getID comes from student. So here it's being treated as a person, here it's being treated as a student. So it can be treated as any of its types as needed to access methods and attributes. Development strategies. When writing programs, there are 2 approaches to planning and programming the project. You have top-down and bottom-up development strategies. Bottom-up development is when independent classes that do not store, extend, or implement any other class, abstract class, or interface in the project are written first, and then classes that only use other classes that are completed are written. This way you can build a class and then compile it. This process continues until all the classes are written. The advantage to this method is that once a file is written, it can be compiled. Top-down. Top-down development is when there are large, broad classes are built to achieve the goals of a project, and then code is modified to accommodate the use of smaller, more defined classes that are created later. The benefit to this approach is that you can build a project without having to plan for a large number of classes and how they relate to each other. UML diagrams. UML diagrams are graphical charts that show how classes relate to each other. The table below, or on the next page, shows the symbols used in UML diagrams. Rectangles represent classes, abstract classes, or interfaces. Add angle bracket interface, angle bracket for interfaces. If something is an abstract class, less than, abstract class, greater than for abstract classes. Arrows with a non-filled tip and a solid line represents an is-a relationship. Arrows with a non-filled tip and a dotted line represent an is-a relationship with an interface. An arrow with a filled tip that is horizontal or downward is a has-a relationship. Usually when you're pointing upward, you're pointing to things that you're derived from, and when you're pointing downward, you're pointing to things that you contain. Here's an example of a UML diagram. So we have a comparable interface. A person might be a comparable. If they are a comparable, that means they agreed to write the compare to method. But a person would have a name, address, and a phone number. And then we have a solid line pointing up to person saying a student is a person. And a student would have a list of classes they're enrolled in and GPA, and those are has-a relationships. But student has an is-a relationship to person. Differences in file types. A class can store public attributes, private attributes, it can have constructors, it can have static methods, it can have non-static methods, and you can create objects from a class. The only thing a class cannot do is have abstract methods, because when you add abstract methods to something, it means it's not a fully formed idea, and you can't create from them. So classes can't have abstract methods. Interfaces can have public attributes, static methods, and abstract methods. That's it. You can't put that much code in an interface. Abstract classes can have public attributes, private attributes, constructors, static methods, non-static methods, abstract methods. It can have everything, except you can't create instances of them, because an abstract class will likely have an abstract method, and that means your idea is not fully formed. So you cannot have so you cannot create an object from an abstract class. So you might wonder, why do they have a constructor? Well, abstract methods have constructors because subclasses are going to need to extend the abstract class and may need to set some of the private data it has. All right,